4.2 mean value theorem talks about how to find mean value, like a mean grade of your grades. That's the average, right? So we start with this theorem that says if function is continuous or behaves nicely on the closed interval and differentiable. What does it mean to be differentiable? It has a derivative. Don't overthink that, right? But also, if you remember, it means it doesn't have cusps and those kind of weird stuff. So it's continuous, no gaps, no breaks, suddenly, no vertical, horizontal asymptote on closed interval, has derivative everywhere in the open interval. And these edges match, f of A matches f of B, then we can find a point C where derivative is 0. That if you imagine you're throwing a ball, you're on the floor, you throw a ball, it goes up and it goes down to the floor, and there should be a moment when it reached the maximum height, and there derivative is 0. So that's what that C is. The C is the location of that maximum point or minimum point. As you can understand, derivative is 0 is not only at maximum, it also can be 0 at minimum. So that's Rolle's theorem. And they will be asking you to find that C and blah, 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 or at least justify it exists. Function should be continuous and differentiable, so it behaves nicely. It's smooth function with no gaps, which is very nice. Mean value theorem says, on this idea, we're gonna hop on and figure out what is average. Well, if that C exists, you can just copy paste with like this kind of thingy. F is continuous on closed interval, differential on open interval A and B. Remember, see it's open, that's kind of important. The function doesn't have a derivative at the edge, because in order to have derivative, we need to have left and right limit. But on the edge, one side limit is missing. So at A, left-hand side limit is not there, because there's nothing behind A. And same thing for B. So differentiability is on the open interval. Then there will be that C point where we can find the average. And if you remember, the average is change in height over change in rise over change in run. Delta Y over delta X. That is what they say here. And that will happen at that C. At that C. That is an interesting idea here. We're going to briefly practice these problems. To be honest, it's not the most important chapter of the class, so I tend to go pretty fast through it. The idea happens to have something in common with the secant line and tangent line. So here's the picture. Here's the ball. It's going up and going down. Okay, fine. And then we know the tangent line. The tangent line, it's this line that touches the graph of the function only one point. So it's a kiss, right? It's a touch. Secant line from A to B, it cuts through. Secant, secant means cutting through. Well, interestingly, that the slope of that tangent line will be at the location C we already agreed we can find, and it will be parallel to the secant line, which gives you the average. A bit confusing, but I have a cool animation to show you. So the lines are parallel and their slopes are equal. If they're parallel to each other, the slopes are equal. So those are the same numbers. So in this case, slope of tangent line and slope of secant line match. And it happens at that C. So I would say you first find secant line, and then you can claim that the slope of a tangent line will be the same as the slope of that secant line. So I think I have a nice animation to show you that. Please don't be gradebook. Okay, good. Because I just posted 300 grades. I was afraid the gradebook will open. No. Oh, here it is. So mean value theorem, check it out. At some point, you see there's a secant line is already cutting it through. Here it is. The secant line is in red. From A to B, here's my secant line. It has some average. What's the average change of my profit of my business from January till March? Well, the profit is decreasing, but what is the average decrease? And that's why slope will be negative. So it will be the change in months, the change in heights of profits over the change of months, right? The biggest profit minus the smallest profit over March minus January. Does it make sense? That's the average of your grades, for example. So at some point, there will be a point C between A and B where there will be a tangent line parallel to the secant line. That is the idea. Here is even better on the more interesting graph. Again, what if it's profit of your business? That's how we teach in business classes, but I feel it's kind of interesting. So none of you doing anything on Amazon or selling your amazing soap on TikTok? Surprising. So the function is decreasing and increasing. That's your profit function. What's the average change? Take the first, take the last, divide by the length of the interval. But then at some point, or maybe several points, there will be a point C, in this case there are several, where the tangent line will be parallel for the average secant line. So that's very interesting. Kind of it's like with driving. What's the average speed you drove from here to Tucson? 55 miles per hour. Well, you did not drive all the way 55 miles per hour, but it was moment in time when you did. That is the idea here. There was a moment in time between being 95 miles per hour, then you notice the policeman start decreasing slowly, decreased to 45, and again increased to 75. At some point, there was exactly, what did I say was the average? 55 miles per hour. At some point, you did it. Yes?
Didn't we have something similar before where it was like, if the graph is continuous and it's at one point it's at 2 and another point's at 5, it must have been at 4.
Exactly. Very good that you remember that. Continuity. Remember that if function is continuous, you cannot jump through that number. If you were driving 45 miles per hour and at some point 95 miles per hour, guess what? At some point you were driving 55 miles per hour. But in this case, you know it's different. You're right. We had this before. In this case, that 55 miles per hour matches the average speed. So you first find the average speed, and then you can claim using theorem that at some point that number happened. So that is the idea here. I have better explanation using the driving. Americans drive everywhere like Europeans and many Asian cultures. So I like explaining it through the car because I know you can relate to that. The following situation follows the interpretation. Imagine driving for 2 hours to a town 100 miles away. While your average speed is 100 over 2, 50 miles per hour. Does that make sense? 50 miles per hour. That's your average. Because you drove 100 miles for 2 hours, right? That's the average. Your instantaneous speed, what is instantaneous speed? Tangent line. Measured by your speedometer. How does speedometer know your instantaneous speed right now? It uses math. It was different at all different times. But at some point, that's what mean value theorem says. At some point, there was a point during the trip that your instantaneous speed was the same as average speed, which is 50 miles per hour. So your car was driving faster, slower. And then the average ended up to be 50 miles per hour. But at some point during your trip, you had a speed. Maybe even several points, maybe over here, you had speed 50 miles per hour. That is the idea. So you drove for 2 hours and you went through 100 miles. That gives you average 50 miles per hour. 50 miles per hour. Make sense? Derivative of the distance. Miles differentiates with respect to hours. Miles over hours, 100 over 250. So that's supposed to some kind of connect with the idea of you driving. Did it work a little bit? I feel like driving should help. Let's do example from your homework. Find the average slope for the given function. Good point. So the function was going up and down, up and down. What's the average? Well, average where? They're supposed to give you a closed interval. That's part of the theorem. I don't know, the average on the infinity. We cannot do that for all functions. What if it has a break? And it does have a vertical asymptote at 0 in this case. But we avoided 0 on 1/2 and 2 closed interval. The function is continuous. Solution. Find the average, that's slope, S got deleted. Find the average slope, average mean for the function x plus 1 all over x on the given closed interval. First, let's check if we can use the theorem. We need to check two things, and that's what they're going to ask you, maybe on a test and definitely in the homework. The first thing we need to check if function is continuous. But it's not. Do you see there's a vertical asymptote at 0? Cannot divide by 0. But it is continuous on the interval we chose. And that's why domain is so important. On the interval 1/2 and 2, it is continuous. Make sense? That's why it's so important. You are, as a scientist, choose where to look at it. Here's the graph. This is bad. We cannot use Rolle's theorem here. But I can use it at 1/2, somewhere over here, till 2, and then including the endpoints. This is the function I'm looking at. They asked me to find the average. What's the average of this decrease? So check mark, they have that. And the second thing, still not good enough. What if it has cusps? I want to know that it is differentiable. Well, it is differentiable on the open interval 1/2 and 2. A, you can find a derivative, that's how you know. But B, you can check using definition with left limit and right limit. And remember the delta H at the denominator shrinks to 0. That's the idea, that's the definition. You did the homework problems, check that the function is differentiable. Thus, we can use mean value theorem. Thus, by MVT, that's very American notation. People agreed in this country finally about that. It's MVT. But not anywhere else at all. All different languages call it differently. But the formula is the same. It says there is C that belongs to the open interval, not at the edges. Do you know what this little sign means? C with a tongue means belongs, or at, or from, belongs. So C with a little tongue. Such that, and the formula says that derivative at that C will be the same as average. F at B minus F at A, B minus A. Right hand side in this case is the average. So let me actually put it, let me keep it. So average, that's what they want us to find. And then this is tangent. Well, this is slope. And the whole point of this theorem that, oh, they're the same. Average and the slope are the same. So instead of finding the derivative, you can find the average. Or instead of average, you can find a derivative. That's the idea. So the thing is, we want to know where it's happening. Where is that C? So that's what we don't know. Find C. Let's do that. And I'll give you steps how to find. Step 1, find what you can find, and we can find FB, FA, B minus A. We're gonna do that. F at B minus F at A all over B minus A equals. We can find that. What is B? 2. What is A? 1/2, and 2 minus 1/2. We did something like this before when we were looking at the slope of the secant line the first week of classes. So you plug it into your function, which is 2 plus 1 over 2 minus 1/2 plus 1 over 1/2. Copy paste into the original function over 3/2. Oh, you know what? Also the problem with it's not a big problem with master exam. I was taking it, and now after grading your exam 2, I mentioned last time many of you have problems with algebra. Again, which is fine, but you need to improve it. And that's why I will never shame people when they forget what is 2 times 17, or 2 over 1/2 is 4. But you need to improve it because you will suffer all your STEM major losing points, and in general. Master exam have lots of algebra. If there's no calculator, it has 1/2 minus 3/7, and can you do that? So no decimals. I think that's what they're also doing. They want to filter people not to move on to calculus 2 if they cannot differentiate and the algebra is way too bad. So again, it's not a punishment. It's for you to know you need to improve ASAP, like right now. Urgent. While I was talking, did you calculate the result? With no calculator. -1. Is it weird that it's negative though? Some people put it on the exam 1. I don't know why it's negative, but like, is it weird? It's not weird. Why? How do you know?
Because it's sloping downward.
It's going down, so decreasing, right? We can expect it to be negative. The average will be negative. So the average, we're talking about the slope of the average. The slope, it looks like this. This is what we're talking about. You can do this graph later if you want, at the end. From A to B, we're finding the average. This is the average. Average as a secant line connects the endpoints. And this secant end up to be -1. So the slope of that secant end up to be -1. Makes sense because the profit or whatever this function represents is decreasing. Minus means decreasing. Step 2. Now find derivative of this function. X plus 1 over x. You will have to do lots of quotient rules on the mastery exam on Wednesday. Perform the quotient rule, square the denominator first, not to forget about it. And then I will speed up. 1 times x minus x plus 1 times 1 equals -1 over x squared. Also going to be negative. That makes sense. We can agree with that. Step 3. To find C, we're going to use the formula from the mean value theorem. 1 equals to 2. 1 equals to 2. Step 1. Okay, step 1, set it equal to step 2 and solve. Step 1, set it equal to step 2 and solve for the unknown. The theorem says -1 from the left, let me color code it or something. -1 will be in green. -1 from the left hand side will equal right hand side at C -1 over C squared. So I'll put this in the box. Maybe like point at it. So that's what the formula says. Let's stare at the formula again. At C, a derivative matches with the average. Well, we found the average and we found derivative everywhere. So now if I plug C into derivative, it must give me -1. So that's what I did. Plug C into derivative. Maybe I should write down. Plug C into derivative. That will give me moment in time when the average speed of you driving the car matches with the actual speed you were driving the car. Instantaneous speed. While I was talking, did you solve it? So let's solve. How do you solve it?
X1. I mean C1.
C squared equals to 1, right? So get rid of negative sign, multiply, do common denominator, whatever you know how to do it, but solve it. That means C you said equals to 1. Panda is crying.
But I mean, it could be equal to -1, but it's not.
Yeah, but you need to first make sure math is right.
Yeah.
Math goes first and then the domain. Domain is a restriction, so restrictions can be changing from time to time. Panda is crying if you forgot negative. Don't forget
It
that.
can't be negative one in this case because
That's-
if we take root, then it would be imaginary.
Yeah. No. You're confusing the square root of -1. In this case, -1 squared is still 1. So we have to include both. 1 squared is 1 and minus squared. And -1 squared is also 1. So this is almost the answer. Step 4. And again, if you follow my steps, you can solve this homework and exam problem, which is going to be exam 3, easily. Check the domain. We don't want extras. The domain is 1/2 and 2. This whole theorem says, let's go back, here it is, that C have to be on this open interval A and B. So we cannot even include endpoints, right? So we have to check if we got extras. Kick out the extras. So I will even and even open parentheses. So you cannot even include the endpoints by the definition. So yeah, we have to kick out -1. Answer. C equals to 1. And then C equals -1 got kicked out because of the domain. What do you think about that? On the graph, please copy the graph quickly. So the whole function simplified, let me finish just a second. So the whole function simplified to be looking like 1 over x. That's the graph of 1 over x, if you remember, hyperbolic function. Check it out. So I connecting A and B, which is 1/2 and 2, and creating a secant line. That is average. Average. Average is a slope of the secant line. Average slope. That's why it's called M secant or M average. That's not the normal M. Usually M is the tangent line. And then I'm gonna put in blue the tangent line. Here it is. But what kind of tangent line? We have infinitely many tangent lines. We want some kind of tangent line where it has the same slope. So parallel to this guy. That means this M is also -1. Matches. The question, that's based on the theorem. The question is, where is it happening? It's happening at 1, and I totally missed the 1 location. Let's pretend it was not there. So, where is it happening? You were driving from 1/2 to 2, hundreds of miles. I guess half of the 100 and then 200. So, average speed was decreasing. At some point, you had that exact speed on a speedometer. Where did it happen? At 1. That's how you can see it. Oh, this is C. C is the location. It's like when it happened. When it happened, or location of this beautiful situation when a secant line ended up to be parallel to the tangent line. Yes?
So like in the original question, it was asking for just the average slope.
Yeah, that's the one.
Is the C, so the to find C part is like more extra stuff?
Oh, good question, good question. So the question says, find the average slope, find the, yeah, that's a good point. He's right. The question says find the average slope, so you could just find the average and then prove that it's the same, blah, blah, blah. Find the average slope as a point. Oh, that will be good. Now we can say where it is. So C gives me the location of it. And then -1 was the height. No, -1 is not the height. Find the C. I guess let's just be very specific about it then. Find the C. Yeah, that's how to like phrase it nice. Find the point where, find the C, oh yeah, find the C where the average mean slope is happening. Oh, average mean slope, yeah. Do you guys know what's the question here? Slope was -1, so that's not the same thing. And C became 1. C is not the same as -1. C is when it's happening. What moment of time, for example. So find C where the average mean slope is. Or like this equals, I guess let's do is. And then for the given function, I will do like this. Oh, maybe like that. Kind of bad English here. Good point. I should check how they say it in web work. But in general, they will always be asking you not to find the average because it's easy. Average is just rise over run. They always will be asking to find it C, which is harder, and that's what they want you to find. Good point. People, any questions? This chapter has a very deep idea behind it, but when you actually go to calculations, it's pretty boring. So average, tangent, the same, they're parallel. Yay! But actually, mathematically speaking, it's a big idea here. No questions? No concerns? People looked concerned and sleepy after partying at Halloween. Very sleepy. Then let's move on to the important stuff that happens after this. For the next 2 weeks, we can have extremely important stuff.